So we are going to talk about Java SE 8 and beyond. So what are our plans for things that go beyond Java SE 8? Now, one of the things that you learn when you first join Oracle, and having spent nearly 15 years working at Sun, one of the first things you learn when you join Oracle is lawyers get involved. And so all of my presentations now have to have this statement, which is called a safe harbor statement. And essentially, it's all about saying, don't base any of your purchasing decisions on anything that I tell you about the future. Which, since we give away most of Java for free, I don't think is really too much of an issue. But I have to put this up anyway. Right. Now, if we look at the history of Java, this is what we have, really. Back in the very early days of Java, we released the first version 1.0. Now, who used version 1.0 of Java? One or two people. Okay. So version 1.0 came out, and then obviously progress was made, and we added various things to that. So we came out with version 1.1, version 1.2, version 1.3, version 1.4. Everything good up until this point. Very logical. Then marketing got involved. And so we went from version 1.4 to version 5.0 in one leap. But because engineering was still involved, if you look at the version number that actually gets recorded in the JVM, it's actually version 1.5, even though we called it 5.0. Then, about 6 years ago, we came out with Java SE 6. And at that point, we decided that there was not going to be a Java 3, so we'd also dropped the Java 2. So it became Java SE 6. And we dropped the .0 because we also said that there was never going to be a 6.1. So let's just standardize on 6. And then last year, after the Oracle acquisition of Sun, we released Java SE 7, something that had been a long time in the coming. And that was a number of reasons which caused the delay in the release of Java SE 7. There was the issue of Sun open sourcing the Java development kit. A lot of people think we open sourced Java. We didn't. We open sourced the Sun implementation of the Java virtual machine, the Java development kit. And that actually took a lot more engineering resources than we at first thought. And then there was JavaFX, which was another thing that we did, which took more engineering resources than we thought. And then there was the whole being acquired by Sun thing, which distracted a few of us from what we were doing on a day-to-day basis. And looking to the future, obviously the next versions will be version 8 and version 9 and, logically, version 10. Now, when it comes to actually thinking about how we change Java, we've always been very concerned about doing it in a way which makes sense. If you have a lot of people using a programming language, what is the worst thing you can do in terms of changing it to a new version? Well, personally, I think that if I have working code for version X, and I have to move that to version X+1, and I take my working code, and then I have to change it in order to make it work on version X+1. The problem is that if I break backwards compatibility, or if we break backwards compatibility, you have to take working code and modify it in order for it to work. And that's really not a good thing. And we've been very concerned with backwards compatibility. Now, you can argue that, and some people would say, that we've been too concerned with backwards compatibility. Looking at the way that things like generics have been implemented, looking at the way that we have deprecated literally hundreds of methods and never removed a single one from any of the packages, could be considered a little bit overzealous in terms of how we actually make changes. But it does mean that backwards compatibility is very good. Not always perfect. If you look at Java SE 1.4, we introduced assertions, and that introduced a new reserved word, assert. So if you'd used assert as a variable name, you would have to change your code. Similarly, when we introduced Java SE 5, we introduced enumerations, and that introduced a new keyword, enum, which again meant you had to change your code if you'd use that as a variable name. But there are other things that we need to consider in terms of changing the language. There were some guiding principles that were used by people like James Gosling when Java was first created. And what those primarily were was about making Java readable, making it easy to understand what it was that people meant in the code that they've written. Now, I know from experience that it's actually very possible to write very unreadable Java code. I've seen lots of it, and it's very difficult to understand. But the ideas behind the language are that if you write good code and you think about it, it's actually possible to make it readable for other people. So let's have a show of hands. Has anybody here ever used the programming language Perl? Perl. Yes, a few people. Okay, I'm going to upset you in a moment. I personally think that Perl is a write-only language. Once you've written it, it's impossible to understand what it was you wrote. Now, I am being unfair to Perl. Perl I've used in the past. It is a very powerful language. You can do an enormous amount with only a few characters. And that's one of the things that makes it very powerful. But it does make it hard to understand what somebody else has done once you've actually written the code. And we want to try and avoid that with Java. We want to make sure that Java maintains this idea of readability. We also want to try and avoid hiding things from you by the compiler. So we want you to be able to understand what is actually going on. And again, one of the things that we've done in the past, which is a good example of how we didn't do that very well, was auto-boxing and unboxing. Java is not a purely object-oriented language. We have primitive values, and if you want to store those in something like a collection, you need to make them into an object representation. You have to encapsulate them in a wrapper class. And so you have to instantiate an object and put it into the collection. Auto-boxing and unboxing is the idea that if you say add a primitive value to a collection, the compiler will say, oh, okay, you just need to wrap that in an object. We'll do that for you and put the object into the collection. Similarly, on the way out, if you want to extract a value and assign it to a primitive variable, then the compiler will unbox it for you. That's all well and good and sounds very usable. But if you look at things like Josh Bloch's book of Java Puzzlers, he comes up with some very good examples where Java hides things from you by using the compiler, and you get some very subtle, very hard to find bugs. So we do need to be very careful when it comes to how we change Java. Now, the next thing is the process of changing Java. There is this thing called the Java community process, and there are many JSRs, Java specification requests. The concept here is to try and hit a middle point between the two ends of the spectrum when it comes to how standards are developed. On the one hand, you have the idea of one company controls everything. They simply say, this is what you get, and you have no choice. You have no say in what actually happens to the development of that language. On the other end, you have the fully open standards process. You have things like the OSI, you have things like XOpen, POSIX, various people like that. And the problem with that is that even though everybody gets to contribute to the development of that standard, you can have enormous arguments that go on for days or even weeks about the most minute detail. And I speak from experience because I was actually involved in some of the XOpen work a long time ago. So we wanted something that would move along at a reasonable pace, but allow other companies, other individuals to be involved. And that's how the JCP came about. What we want to do now is to make sure that the JCP still addresses in the right way all of the needs of people developing Java standards. So we've done a couple of things recently, and we're still in the process of changing things to make the JCP better. We've added some new members to the executive committee, who are the people who decide which JSRs should be allowed to go forward. So there's people like Sujava, who are the biggest Java user group in Brazil. They have literally tens of thousands of members. I have to say most of them don't turn up at every meeting, but they certainly are very active. And then there's the London Java community, again, very active group in the UK. And because Java gets used a lot in financial applications, we got Goldman Sachs involved so that they could represent the needs of those types of institution. The other thing we want to do is to make the process itself more transparent. So things like publishing all of the mailing lists of the discussion about how a standard is being developed. That way you don't have to wait until the public review of a standard in order to understand what's actually going on and what things are going to be included. And you can see how the standard is being developed. So if we quickly look at what Java SE7 included, Java SE7 was sometimes referred to as Plan B, because when Oracle acquired Sun, they wanted to get Java moving again. They resolved issues around the JCP, but they also needed to make sure that they had a release of Java SE coming out fairly quickly. And the discussions that went on basically meant that there was a number of things that were almost ready to go, and then there were some things which were going to take a lot longer to finish. So we said, okay, let's take the things that are almost ready, make that Java SE7. Things that are going to take longer, we'll make those Java SE8. So what we got in Java SE7 are some small changes to the language, syntax-wise. But they are small changes. We didn't introduce any new reserved words. We didn't affect the type system. So it's really mostly sort of syntactic sugar, as it's called, around what the compiler can do for you. Some of the things like try with resources, which is a great way of improving the reliability of code when you've got a number of different input streams or output streams, and avoiding nesting complicated try-finally blocks. Simple things like being able to put a binary literal into your code. So if you're doing a bit mask, you can actually see what the binary digits are now. Various things like that that we added to the language side of things. From a class libraries perspective, there were some improvements around input and output, and finally, after 15 years, we now have a single method call that will allow you to file sort. Multi-CPU environment, and I'll come back and talk a little bit more about that in a moment. We made a change to the virtual machine in the sense that we added a new bytecode, the invoke dynamic bytecode, which is all about making it better for languages that were not Java being compiled with bytecodes working on top of JVM. Things like JVM, Java, Scala, compile into bytecodes. We wanted to make it more efficient for them to execute on top of the JVM, because even though the JVM doesn't actually know anything about Java, it was designed with Java in mind. So it's a single inheritance architecture. It uses static typing, and that's the big thing. So invoke dynamic is all about making dynamically typed languages run more efficiently on top of the JVM. In terms of the JSR, number 336, that gives you the details about everything that went into Java SE7. Now, the other thing that happened when Oracle acquired Sun was that they acquired another JVM. They already had the JRocket virtual machine that they got through acquiring BEA, and then they got the hotspot virtual machine from Sun. And the decision was made that it didn't make a lot of sense having two engineering teams developing a JVM in parallel. What we really needed to do was to combine those two teams and create a single converged JVM. And so that's what we're doing. We haven't quite decided on the name yet. My personal preference is JSprocket, but I don't think marketing are going to go for that. But what we're doing is basically taking the hotspot virtual machine code base and then adding features from JRocket to that. Things we're adding are things like the monitoring capabilities. There's mission control, there's flight recorder, there's a deterministic garbage collector which gives you better performance in terms of hitting latency targets and things like that. So those are the kinds of things that are going to be integrated into the converged JVM. And there's already a lot of work going on that. So if we look at Java SE8 and where we're going with that, one of the primary considerations that we have with this is the fact that the architecture of the machines we're using today has changed since Java first came out. Now, not just by the fact that we have different instructions in the instruction set and things like that, but as this graph shows, we have this concept of Moore's law, where the number of transistors that you can squeeze into the same space on a piece of silicon doubles roughly every 18 months to 2 years. Now, that's still going on, and we're still managing to get more transistors into the same space. What we haven't been able to do in the last few years is to increase the clock speed at the same rate. It used to be clock speed went up at roughly the same rate, but now it doesn't. And so in order to take advantage of more transistors, what we're doing is saying, well, rather than just adding more functionality and then increasing the clock speed, let's go down a different route. So if we look at some of the Sun Oracle hardware, back in 2005, we introduced the Spark T1 processor. And rather than having a single processing unit in there, what we did was we had 4 processing units. And then by using hyperthreading, we could overlap 8 sets of instructions on each processing unit, each core, giving us effectively the capability to execute in parallel 32 different sets of instructions. And then in 2007, we increased the number of cores and get more transistors in the same space. We'll increase the number of cores to 8, giving us 64 effective parallel threads. And then just last year, we introduced the T3, which upped the number of hyperthreads to 16, still 8 cores, effectively giving us 128 threads on the same processor that we can execute in parallel. Okay, that's all good for the server side of things, but we're even seeing now on client side the same kind of concept. So phones now, a lot of phones have dual processors. We're seeing phones coming out shortly with quad-core processors. Tablets, again, dual-core, quad-core processors. Laptops, it's pretty much impossible nowadays to buy a new laptop that doesn't have at least 2 cores in the processor. So we need to figure out how to take advantage of this. How can we actually make Java programs take advantage of all these different threads and have things work well? So I have a big disclaimer here. The syntax that I'm going to talk about in the next few slides is not 100% guaranteed. There may still be some changes to the actual syntax before we get to Java SE8. It's probably going to be fairly like I show you, but it's not absolutely guaranteed. So don't come back to me in a year's time and say, you said it was going to be like this, and it's not. So this is my disclaimer. So let's look at a piece of code. Now, this piece of code, I'm pretty sure will not change. So it's a fairly simple piece of code. What we have here is a record of a student. And the student has a number of properties associated with it. A name, a graduation year, and a score. And what we're typically going to do is collect together the scores, the names, and the graduation year of a set of students. So we have a collection. Okay? Then we want to do something with that collection. So what we want to do is we want to be able to look through that collection and search for something in particular. We want to search for the student who had the highest score in the year 2011. So this is one approach that we could take. We can simply say, okay, take my collection of students, set a maximum value to being the smallest possible value we can find, and then iterate over that collection. Iterate over the collection, look for any student who has a graduation year of 2011, and then use the math.max method to figure out which one is the biggest. That is a perfectly valid approach to doing that and solving that problem. The issue that we have with that is that it's difficult, if not impossible, to make that multi-threaded from that piece of code, because there's no easy way to apply a number of threads to that piece of code. We have a single set of instructions which is iterating over the collection. No matter how big it is, we've got one thread working on that collection. And in fact, the way that we explain it is the moment that you have that maximum value as a single representation, you're absolutely like broken when it comes to making it multi-threaded, because you've got all sorts of issues, even if you go down. Interested in the graduation year being a particular year, and then we're interested in recording the maximum score of that set of students. Okay, so we can rewrite this code taking a different approach, still using perfectly valid Java that we have today. And we can do this, which is not a particularly nice looking piece of code, but it means that now we have a situation where, and I'll come back to how we would do this, we could in theory make this more parallel than before. So what we're going to do is we're actually going to use anonymous inner classes. So here we're going to say, okay, take the students collection and call a method on that called filter. Filter requires a method to be used And from that, we'll actually use an anonymous in a class to provide a single accessor method that we can use. So in this case, we're going to create a new predicate class, and type parameter will be student. And then what we're going to do is have an operation that we perform on that, which will simply return true if the graduation year is 2011. We'll then pass that to a map method, which will take an extractor class, or type class, and then that will have an extract method, which will remove the information we're interested in, the score. And then we'll pass that to a reduce method to figure out what is the one score that's the highest. So again, we're going to pass in a minimum value of 0, and we're going to use another anonymous in a class to implement the method that we need, which is reduce, and that will return math.max of the max value and the score. So it's all very good, and it works, and because we're no longer limiting ourselves to a single instance of the maximum value, we could, in theory, make this more parallel. Problem is, inner classes. Inner classes are not the best thing in terms of how they've been designed and how they're actually sort of implemented. So they are imperfect forms of closures. And closures, if you've not used other programming languages that have them, are effectively, in a single sentence, and don't criticize me for describing closures this way, is effectively treating a method call as an object reference, so that you can pass a method as if it were an object from one place to another. So the problem with inner classes is that they do have very bulky syntax. The issues around non-final local variables, because you can only use a final variable within an anonymous inner class from outside of the inner class. Problems around what does it mean when we say return, what does it mean when we say break, continue. If we refer to this, does it refer to this in the anonymous inner class, or does it refer to this as in the outer class? And non-local control flow operators, things like that. So we have an issue. Now, we use single abstract method types a lot in Java. If you've ever used Swing or AWT, things like that, even if you've used threads in the past, then you've used single abstract method types. These are classes which have a single method, which is abstract. You have to implement it. So things like an action event is, or an action listener, is a single abstract method type. And what you end up with is bulky syntax, where you've got 5 lines of code, even if your method that you want to call only has 1 line of code. You've got to surround it by this extra noise, if you like. What we're proposing to do in Java SE 8 is to replace this with the concept of a lambda expression, which is like a closure. It's a closure form of construct, but it's not a complete closure. So it's not like closures in other classes, other languages, sorry. So what we end up with is a different syntax for the way that we would use the previous example. So here what we're going to do is we're going to take our collection of students. We still want to use the filter, map, reduce way of analyzing the data. But this time, rather than using an anonymous in a class, what we're going to do is we're going to say, okay, let's say for the filter, we will pass in a lambda expression. And because a lambda expression is in effect like a method call, what we're saying is that on the left, we've got student S, which is the parameter that we're passing to our method. Then we have a single bar arrow. And on the right-hand side of that is the body of the method, in effect. So it's the set of instructions that will be executed as a consequence of calling the filter method. And that way we can change what the filter method does based on what we want to do using that lambda expression. Similarly, for the map method, we'll use a parameter, student S. We'll pass that in, and the result will be whether what the score is. So we get the score back. And finally, the reduce method will pass in 0, and again, we'll use a definition of the method as being math.max. But we can go further than that. We can use type inference by the compiler because we know that the collection is of type student, so we don't need to explicitly call that out. So we can reduce that further. We can say filter S to S graduation year equals 2011, and because the compiler can verify that the type is correct, it doesn't have to worry about class cast exceptions and things like that. And also in terms of the method call, we can use a method call reduction and say math hash max. That's one of those things where I'm not 100% certain about the syntax of that. Just recently I saw that had possibly been changed to a double colon. But again, it's not completely nailed down. So how does that help us? Well, what it allows us to do is to then add in another method call which says make this parallel. And how we make that parallel can be left to the implementation of that method. We don't have to worry about what the actual functionality of that is. But because we're now using a sequence of method calls, we can introduce a parallelism to the way that we process the code. Some more examples of lambda expressions. Okay, so we can have a context C as being our parameter, where we're explicitly specifying the type of the parameter, and then we can have a method body, which is system.out.println, or we can leave out the type and have the compiler infer it for us. And similarly, we can make simple expressions where we just want to add 1 to x. That's perfectly valid as well. There are some rules about what you can and can't do with the way that you use lambda expressions. So rule number 1 is that you can only use a lambda expression in the context where a single abstract method type could also be used. So wherever you would use an anonymous inner class at the moment, that's where you could use a lambda expression. If you can't replace the lambda expression with an anonymous inner class, with a single abstract method, then that's not a valid use of the lambda expression. So we get standard things here, which are normal way of doing things. But the example at the bottom there, object O equals empty set of parameters, returning the value 42, that's not a valid use of a lambda expression, because it's just not, doesn't translate into how we would use a single abstract method type anonymous in a class. There are some other rules. The list of statements on the right-hand side of the arrow is just like a method body. So it's the statements that you would execute in a method body. However, the break or continue, at the, there's no break or continue at the top level. So you can't break out of it into the surrounding code. The return type, because we don't explicitly state that, is inferred by the compiler. If there's more than one place where something can be returned, the compiler will take the appropriate supertype of any types that are being returned, even if that's object. The reference to this is the same as the surrounding code. So this will refer to whatever the code outside of the lambda expression is. And finally, we have the concept of effectively final variables. What that means is that if you want to use a variable from outside of the lambda expression in the surrounding code, you don't have to mark it as being final, but it has to be effectively final. So that means that it would work in exactly the same way if you had marked it final. So you can't have non-final variables accessible within a lambda expression. So any variable that you have access to from outside of the lambda expression doesn't need to be marked final, but must effectively be so. I know that sounds a little bit complicated, but hopefully I've explained what that means. So the other thing that we have to think about here is the way that we've changed things. So this all sounds very nice, doesn't it? Because we can say, okay, filter, map, reduce. That's a standard algorithm, standard pattern that people use. What's the problem here? Well, the problem is that we're using these methods on the collections interface. But the collections interface doesn't currently have filter, map, or reduce. Currently, the collection interface has things like add, size, and clear. So are we now saying that we're going to add methods to the collection interface? Because if we do, that's going to break a lot of backwards compatibility. Because if you're using the collection interface at the moment, and you've got a compiled piece of code which doesn't have map, filter, or reduce in it, and then we create a new piece of code that references that collection interface from somewhere else, if you try and call map on that collection, because it doesn't exist, you're going to get a runtime exception, and it's going to stop. That would be very bad. We have a solution to that. What we're going to do is extend interfaces in a way that, this is also called defender methods. Basically allows us to provide an extension method in an interface where if one is not available because it's an old version of the interface, that was compiled before these methods were added, we will provide a default implementation that can be referenced from the virtual machine. So what we're saying now is that for the example of reduce, what we'll do is we'll say public extension and then give it the reduce method. The default will be to call the set reducer method from the collections utility class. And that way, even if your class file has been compiled without a reduce method, then you will actually still be able to call a method because it will come from the collections utility class. And again, this is one of those things where the syntax is not 100% guaranteed yet. We may be leaving out the extension keyword, again, because that would possibly introduce new keyword into the language, which we might not want to do. So we end up with an extension to the interface collection, and we, yep, well, hang on, where's the question? Yeah, there.
If you want to read up more about that particular bit, what would it generally be under?
So I didn't hear the question.
If you want to read up more about how exactly it works,
oh yes.
What should we refer to?
Oh, okay. Yeah, if you want to understand more about this, if you go to the OpenJDK website, there's actually a very nice paper on lightweight defender methods that explains all of this. So just go to the OpenJDK website, follow the links down to JavaFX 8 and Lambda expressions, and you'll find it there. But lightweight defender methods is what you're looking for. Yes, so that allows us to extend the interface without breaking backwards compatibility. Okay, another thing that we're looking at in JavaFX 8 is modularization. And the issue here is that this is a typical way that we might start an application in Java. You call Java, you pass in the reference to the main class, which contains your static void main entry point. Okay, that's all good. But it doesn't normally look like this. It normally looks like something like this, where you've got lots of jar files that you need to refer to. And so you've got a whole bunch of stuff that you need to reference in order to have your application start up. Now, what we're actually interested in here is only certain parts of the information. We're interested in the fact that it is Java. We're interested in the fact that it is a set of jar files, and we're interested in the particular entry point for main. So what we're going to do now is say, okay, let's use modules in Java. And this will move away from the idea of jar files. So we'll now have modules, where we'll have a module info.java file associated with your module, which is effectively your application. That way we can give it a name, we can give it a version number, which you haven't been able to do before, and then we can tell the compiler and the virtual machine what jar files are required and which version numbers we require so that we can resolve those appropriately, and where the entry point is. So when we start the application, all we have to do is call Java and the name of the module. The virtual machine will pull the information out of the module info.java file and be able to start up the application. And the idea behind this is that we can actually build up the dependency map both at compile time and runtime so that we know that our application has dependencies on these jar files, but those jar files may in themselves have dependencies on other jar files, so all of this graph of dependencies can be built up. And what that will allow us to do is get rid of the class path. So that's a really good idea. Of course, you're still going to need a module path to point at where the modules are coming from. But it's a much simpler way of doing things. The other thing that we can do with this is to improve the efficiency of how we build things. Because at the moment, you can create a jar file, maybe you can create a module file. Wouldn't it be nice if we could generate from this an installable package, so an RPM file or a Debian file, and then take it even further and say, okay, well, let's go from Maven directly, use the module.info.java file, and build the installable package. So all of the information is contained there. We can integrate it with the tools. We can integrate it with the packaging and so on. So what this means is we can get rid of class path, but there's some other things we can do as well. What we're really aiming to do now is to say, okay, well, can we modularize the Java platform as well as Java applications? That way we can target smaller devices where we don't necessarily need all of the classes that are involved in the actual Java platform. The other thing this will do is speed up the startup time because we don't have to load all of the Java platform and the runtime jar file at startup time. We can select which bits we need and have those loaded at startup time. So what this will allow us to do is create profiles and modules for the Java runtime. And so if you don't want Corba support, you don't have to have the Corba module loaded. If you don't want to use Swing, because you're not doing a graphical application, you don't have to have the Swing module loaded. There's still a lot of work going on around this because there's a lot of interdependencies between the different classes in Java. And so separating these out into usable modules is proving to be quite a challenge, but that is what we're working on. So from a contents of Java SE8, this is the kind of thing we're looking at, most of which we've already talked about. So there's Jigsaw, which is modularization of both platform and applications. Project Lambda is Lambda expressions. Convergence of the JVM, already talked about. JavaFX 3, we're talking about including JavaFX, which is now a Java API, into the standard class libraries. Make it easier to deploy, make it easier to use. Better support for JavaScript from the JVM, so that we have a thing called Project Nashorn, which is about improving the efficiency of JavaScript running from within the JVM. Different device support for newer devices, some productivity things around annotations, possibly some other language enhancements and things like that, and some updates to the APIs. Big one there is things like the date and time API finally getting improved. So, the last bit of the talk, I'm going to give you some additional disclaimers. So what I'm going to talk about for the rest of this talk is ideas. This is not what is going to go into the future of Java, guaranteed. And I did this presentation in London a few weeks ago, and there was somebody from the Register, if you've read the Register, in the audience, and they reported on what I said, and it kind of got translated into, Simon said this is what will be in the future of Java. And that's not what I'm saying. I'm saying these are ideas that we are discussing. We may include them, we may not, but they're things that are up for discussion. So the kinds of things that we're looking at are around the big picture, interoperability, cloud computing, ease of use from a language and compiling and writing code perspective, optimizations to improve the efficiency of the language, and making it work everywhere with everything. Now, if we drill into that in just a little bit more detail, interoperability, this is other languages, not just Java. We've already done invoke dynamic to improve the efficiency of dynamically typed languages. We're looking at improving JavaScript in Java SE8. We're thinking about a meta object protocol in JDK 9 as a possibility, not guaranteed, possibility, and a whole list of optimizations to the JVM to improve interoperability, which are going to be JDK 9 and beyond. We're also looking at rewriting the JNI interface, or the JNI code, because JNI is notoriously difficult to use. And in fact, when I spoke to one of our engineers about this, he said, well, it was actually designed to be difficult to use to discourage people from using it, which is not necessarily the best way to design something. But that was what we did. So we're looking at making it much simpler to use JNI in the future. Cloud computing. There are two big things around cloud computing. One is the concept of multi-tenancy, where you have a number of instances of an application potentially running in the same JVM, but with isolated instances. So you don't want people to be able to see data from another instance of an application. So hiding all of the details so that one client's application is completely isolated from another. So there's various things that we're looking at in terms of how we can make that happen using the operating system functionality and so on. Making the JVM hypervisor aware for virtualization. So some things that we can do at a lower level with memory page sharing, lifecycle and so on that would be potentially interesting. Language features. Large data support, this is being proposed for JDK 9. Currently, if you index an array, you have to use a 32-bit value. So we're talking about making that a 64-bit value so you can make really, really, really big arrays. Unified type system. Now, this is one that caused a lot of furore when I talked about this last time. What we're thinking about, and it is only just an idea, it's not guaranteed, just an idea, is should we do away with primitives in Java? Should we get to a point where we say we're going to break backwards compatibility massively? We're going to do a lot of things in Java that will break backwards compatibility, will solve a lot of problems that people have had for a long time. Getting rid of primitive types is one of those things that we're discussing. That would make Java fully object-oriented. And this is one of the things, so the register reported that, as Simon said, Java will become object-oriented. Which, no, it is already object-oriented. It's not fully object-oriented. So that's one of the things we're talking about. Other things around reification, which is to do with generics, improving the efficiency of that, some data structure optimizations with use of structs, multi-dimensional arrays, and various things like that. Integration for modern device support. This is kind of what I've already touched on with multi-touch, location awareness, sensors, and things like that. But also, you know, can we make more use of GPUs? Can we make more use of floating point gate arrays and stuff like that? So effectively, the path forward for Java is open development. The OpenJDK project is an open source project. You can get the code, you can work with it. What we do is we take that code and we build our binary distributions from that. So the source code base is the OpenJDK. And what we're trying to do is to go for a 2-year release cycle for Java SE, which gives us a roadmap for Java SE, which, if we look way into the future, we can predict, going on a 2-year release cycle, that JDK 9 will be sometime in 2015, JDK 10, 2017, and all the way up to JDK 12 in 2021. We are actually thinking internally about what we will be doing in 10 or nearly 10 years' time. So that is the kind of planning that's going on at the moment for Java, is what will happen in 10 years' time. So just to conclude, the platform is continuing to evolve. Java SE 8 is going to add some nice big features, things like Lambda expressions, things like modularization. These are the things that will make a significant difference to some of the code that you write. Going beyond Java SE 8, expect to see some more interesting stuff. You know, lots of possibilities, none of them guaranteed, but lots of things that potentially could go into Java. It's not just going to stay still. And as I've said, you know, Java is not the new COBOL in the sense that, you know, it's a language which hasn't been changed in a long time. Still gets used a little bit, but it hasn't been changed in a long time. We're going to continue to make Java adapt to the needs of developers. Place to go for more information. Both Project Lambda and Project Jigsaw are referenced through the openjdk.java.net project. So that comes back to the question earlier about where to find more about Defender methods. There is a paper under the Lambda project. So that is just about it. So thank you very much.